this particular theorem, Pythagoras theorem, right? Now we're going to prove this theorem. It's going to be very, very, very interesting. Let's understand that. For that we require a triangle. Which triangle? Right angle triangle? No, this is not a right angle triangle right now. Now is it a right angle triangle? Yes. So whatever we have drawn, we write it in the given. So we write the in triangle ABC, angle ABC is equal to 90 degree. That's given to us. Beautiful. Now what we need to do here is we need to prove that hypotenuse square is equal to one side square plus other side square. That means in the to prove, we'll write AC square is equal to AB square plus BC square, isn't it? That's so very simple, right? So we have understood what we are supposed to draw, what is a given and what is a to prove. Now let's proceed further and let's understand how are you going to prove it. Now always remember, whenever we do a proof based sum, right, this is a theorem, always focus on the to prove. That gives us a hint. When we look at the to prove, it says we want AB square, we want BC square, we want AC square. That means we want the square of the side. Now how do we get AC square if I say? AC square means it is AC into AC. How do we get that? I'll explain. It's very simple. Now if you have two ratios which are equal and we have AC in the numerator here, AC in the denominator here. Now AC into AC, cross multiply and you will get AC square. That means in order to get AC square, we require two ratios which are equal, right? Two equal ratios where we have AC in the numerator, AC in the denominator here, right? When do we get ratios equal? We are talking about triangles. Yes, if we have triangles to be similar. But when we talk about similarity of triangles, we require minimum two triangles. How many triangles do we have right now? Only one. So we require one more triangle. But remember, this triangle is a right angle triangle. That means the other triangle should also be a right angle triangle. Now how do you get that right angle triangle here? That is very interesting. It's very simple. Right, from the vertex of a triangle, if you drop a perpendicular on the other side, you will end up getting a right angle triangle. Observe. So from A, can we drop a perpendicular on the opposite side? It's already there. So from A we can't drop because it's already there. From C, there's a perpendicular already dropped there. So we can't have it from C because it's already there. So now we can drop a perpendicular only from one vertex which is remaining, that is B. So from B now we drop a perpendicular on its opposite side, and what we end up getting now is a right angle triangle. Not 1, 2, 1, 2. So we got 2. But we require only 2 right angle triangles. Okay, that we'll consider. So now we write in the construction. What is the construction? We write draw segment BD perpendicular to hypotenuse AC such that A dash D dash C. So is the logic for the construction clear? So why we have drawn this? So that we have right angle triangle. Now we have it. So we have to just enter into similarity. Now I want you to think. Observe, we have a right angle triangle, and here from the vertex of the right angle there's a perpendicular on the hypotenuse. What happens in such a case? In such a case we know one thing which we have learned, that all the three triangles, that is the two smaller triangle and the bigger triangle, they are similar to each other, isn't it? They are similar. And how do we get that? By similarity of right angle triangle. So how do we write it? We know the presentation. Let's write it. So write in triangle ABC, angle ABC is equal to 90 degree, segment BD perpendicular to hypotenuse AC. What is the reason for that? It was not given. The reason is construction. So do write that. And then we write, now we get the three triangles similar. You know how to write the names of the three triangles. Very important. 1-to-1 correspondence. We have learned a trick. What is that? First write the name of the bigger triangle with 90 degree angle in between. So we write here triangle ABC. That's it. Then the name of the next one. For that, pick up this point. That is D. Write D between the first two alphabets there. So what do we get? Triangle ADB. Beautiful. Now write D between the next two, that is between B and C. So what do we get? It is triangle BDC. These are the three triangles which are similar to each other, and they are as per 1-to-1 correspondence of the vertices. Very important. What is the reason for that? We know the reason. The reason is nothing but similarity of right angle triangles, and that is our result number 1. We got this. Beautiful. Now we got the triangles similar, right? Why did we do that? Why did we prove the triangles to be similar? We proved it because we wanted ratios to get equal. Okay, now look at what we want. We want AC square. That means if we want AC square, we require AC 2 times. That means we require 2 triangles which contain AC. Now look here and tell me, do we have AC? Yes, we have a triangle which has AC. Do we have it here? No. Do we have it here? No. That means, remember one thing, we can't get AC square. That means we can't get the left hand side. Forget. Come on to the right hand side. On the right hand side, what do we have? AB square. Let's focus. Let's search for two triangles which have AB. Do we have AB here? Yes, that's the first triangle which you're going to consider. Do we have one more triangle with AB? That's the second one. So for AB square, we're going to consider those two triangles. So we write that. Pick up those two triangles. From where did we get that? We got it from 1. Beautiful. Isn't that easy? Are you understanding why we are taking that? That's very important when we do a proof. Always understand the logic and then write the statement. So you'll never ever forget it because you're not remembering anything, right? Now, we got this. Why are we taking these two triangles? Because we want AB square. So pick up the ratios which contain AB, right? That's going to be very interesting now. So when we take ratios here, AB, right? So we have AB here. What is the corresponding of that? That we're going to write. The next AB is going to be from the other triangle in the denominator here. So keep it first. One in the numerator, one in the denominator here, right? Beautiful. Now write the corresponding. What is the corresponding side of AB? It is AD. So we write AB upon AD. That is equal to, what is there here? Right? Here we have AB. For that the corresponding is nothing but AC. So we write that AB upon AD is equal to AC upon AB. Wasn't that easy? What is the reason for that? CSST, corresponding sides of similar triangles. Why did we do that? To get AB square. So can we cross multiply? Yes, we can. So now we write AB into AB is AB square is equal to AC into AD. That is what we get. And that's our result number 2. So my dear child, remember why did we do that? To get AB square. Did we get that? Yes. What is the next? Now you'll say we want BC square. And I know you're very smart enough to tell me how will you get BC square. How? You're very correct. We need to identify two triangles which contain BC. Which contain BC? The first one and the third one there. So we're going to pick those two and write there triangle ABC is similar to triangle BDC. From where? It is from 1. Now we're going to pick up ratios and in those ratios we're going to write 1 BC in the numerator, 1 BC in the denominator. Now pick up the corresponding sides of that. BC, for that what's the corresponding side? It is DC. Beautiful, we wrote that. And for this BC, what is the corresponding? The corresponding is AC, so we write that, right? Wasn't that easy? The reason is CSST. Now just cross multiply. What do we get? BC square is equal to AC into DC. We got that, and that's the result number 3. Was that easy? Very easy, right? Now you know what has happened. We wanted AB square, we got that. We wanted BC square, we got that. Where did we get it? In result number 2 and result number 3. But what are we supposed to do with AB square and BC square? We are supposed to add them, isn't it? We need to add them. That means we have to add result number 2 and result number 3. Now when we are adding two results, that means we are adding the left hand sides and adding the right hand sides, isn't it? Now let's do that. So what do we get? AB square plus BC square on the left hand side. The reason there what you are writing is adding 2 and 3, right? Equal to, now the right hand side. What is that? AD into AC, right? That is the right hand side of result number 2 plus the right hand side of result number 3. That is DC into AC. Was that easy? Very easy. Simple. Now left hand side AB square plus BC square. What we wanted we got there. Keep it as it is. So we write AB square plus BC square equal to, look at the right hand side. You got two terms here, two terms, one term here, one term here, right? Two terms, addition. Is there something common there? Observe. AC, AC, beautiful. We got AC common there. Wow, beautiful. So if you got AC common, take AC common there. So within the bracket, what do we have? Here, what is left is AD, and here what is left is DC. So within the bracket, we'll have AD plus DC. Was that easy? Very simple, right? Solve it further. So we get AB square plus BC square is equal to AC remains as it is. What is AD plus DC? Observe that in the figure. AD plus DC. AD plus DC. What is that? It is nothing but, it is AD plus DC, we know is nothing but AC. So we write there as AC. What is the reason for that? A dash, D dash, C. Very simple. So now look at the right hand side. What do we get? Left hand side would remain as it is. AB square plus BC square equal to, on the right hand side, AC into AC. What is that? AC square. So haven't we got what we had to prove? It's so simple. We had to prove AC square is equal to AB square plus BC square. We got that. AC square is equal to AB square plus BC square. Wasn't that easy? Very, very, very simple. You can just rewrite it the same way like this. AC square is equal to AB square plus BC square. And we got it. Beautiful. Very, very, very important theorem.
And yes, please do not forget to like, share, subscribe and press the bell icon.